Have you ever wondered what's in your device? What holds the components together and connects them together? Well, stick around as I give you an engineer's understanding of what a PCB board is. Hey guys, I'm MJ Sandra, your average engineer, and I'm gonna give you a simple definition of what a PCB is. A PCB, or a printed circuit board, is a component that mechanically supports and electrically connects components using pathways etched from copper sheets laminated onto a non-conductive substrate. Now, before PCBs and before electrical components were actually small and compact, they were actually huge and required a lot of bulky cables and unreliable design connectors, which needed a lot of sockets and constant maintenance. This proved to be an engineering problem, and even though electrical circuits and components were an innovation, this design still had many problems. However, as engineers, we tend to strive for perfection by taking the best and making it better, and if it does not exist, we design it. Thus comes in the printed circuit board, which was created in the early 20th century, around 1925, when American inventor Charles Duckes created an electrical pathway using an insulated surface. Moving further into the future, Australian engineer Paul Ersler created a printed circuit as part of a radio set while working in England in 1936. His PCB design involved the etching of a circuit on a copper foil bonded to a glass reinforced non-conductive substrate. This technique proved to be reliable, so the British and US government used PCBs to develop proximity field sensors, which were used in artillery shells and bombs during the World War II. Fast forward into the future, as electrical components began to move from vacuum tubes and relays to silicon and integrated circuits, the size and cost of electrical components began to decrease. Electronics thus became more prevalent in consumer goods, and the pressure to reduce the size and manufacturing cost of electronic components drove manufacturers to look for better solutions. Thus, the PCB was then integrated and has been used ever since. PCBs are made up from a variety of electrical components produced during the manufacturing process and are decided during the schematic design of the PCB before it is made. Now, diving into how PCBs connect components together, I created a simple PCB Arduino board using Altium Designer. You can create one using SolidWorks as well. Now, checking this design, a simple standard PCB in its most basic form is just a plastic board covered in fiberglass. The components are then mounted on a non-conductive board and connected with small pathways called traces. These traces allow electrical components across the board to function by passing electricity through. Now, PCBs also have small holes which are drilled where each component needs to be placed. A circuit board, if it's a single-handed one, has one layer of conducting material, which is usually copper, on one side of the board, and on another side that's used for incorporating different electrical components on the board. The components themselves on each individual board are essential in making these PCBs work and allowing electricity or energy to pass through them. Such of these components include capacitors, resistors, transistors, diodes, microchips, and so on. PCBs have proven to be an efficient form to mechanically support and electrically connect components together. And because of that, they've proven to have many advantages. Due to their compact size, many components can fit in a PCB board itself. Instead of using wires to connect these components, we use copper tracks, which is proven to be better. They're easy to diagnose and repair. With a PCB, the board has labels which indicate the electronic component's polarity. Thus, you can quickly check for problems and make replacements. Another advantage is that PCBs are time-saving. Due to the labels on the PCB indicating each electronic component and its polarity, you can quickly attach and assemble every electronic component needed. This saves time and allows you to produce more PCBs than needed. In this era, the consumer market has expanded with the rising demand of smartphones, smartwatches, and smart TVs, and so on. Health monitoring and implantable devices are becoming common in our everyday life, as well as the use of safety devices such as CCTV and fire alarms that require tiny PCBs in order to operate effectively. On the other hand, advanced applications in aerospace, telecommunications, and military require complex PCBs for reliable and robust performance, including the development in the automotive industry, such as electric vehicles and automobiles. The designs of PCBs are taken to a whole different level. This has been a success for the tech industry, but at the same time, as more devices are being made, there are more electronic waste being produced from the PCB industry, which has now raised environmental concerns. To fix this, biodegradable materials are considered as an alternative in order to replace the existing hazardous substances. This shows why technological innovations are important for PCBs as well in the electronic industry. PCBs have wide applications and have been proven to have many advantages. And over the years, we're going to see so much technology rise and improve because of this simple component. On whatever device you're watching this video, it has a PCB board in it. And I hope that this video was able to help you understand how PCBs work. Thank you for watching. I'm MJ Sandro, your average engineer. If you like this video, hit the like button. And if you want to watch more and stay updated on the next upcoming videos, hit the subscribe button. And I hope to see you again on the upcoming video. Have a great week and God bless you.